Today we're on page 324 of our textbook, lesson 16 of unit 10, the algebra of functions. We'll be covering the two pages 324 and 325. Just as two real numbers can be combined by the operations of addition, subtraction, multiplication, and division to form other real numbers, two functions can be combined to create new functions. For example, the functions given by f of x equals 2x minus 3 and g of x equals x squared minus 1 can be combined to form the sum, difference, product, and quotient of f and g. And we have the example of each of the four operations worked out for us. F of x plus g of x, we would take f of x, which is 2x minus 3, plus g of x, x squared minus 1, and combine any like terms, getting the sum x squared plus 2x minus 4. Subtraction is also worked out for us, multiplication, and then division. The domain of an arithmetic combination of functions f and g consists of all real numbers that are common to the domains of f and g. In the case of the quotient, f of x divided by g of x, there are further restrictions so that g of x does not equal 0. Remember, we can never have division by 0. Let f and g be two functions with overlapping domains. Then for all x common to both domains, the sum, difference, product, and quotient are defined as follows. So just another way of writing f of x plus g of x can be written as f plus g of x. The difference, f minus g of x, is equivalent to f of x subtract g of x. And the product, fg of x, is equivalent to f of x times g of x, and quotient f divided by g of x is equivalent to f of x divided by g of x. G of x cannot equal 0. So let's go to it. Finding the sum of two functions. We have f of x is 2x plus 1 and g of x, x squared plus 2x minus 1. Find f plus g of x and then evaluate the sum when x equals 3. This is just notation here. F plus g of x means we take f of x plus g of x. F of x is 2x plus 1. G of x is x squared plus 2x minus 1. Combine any and all like terms. And we have x squared plus 4x. That's it. X squared plus 4x. Now, f plus g of 3, we want to evaluate f plus g of 3 would equal, I can simply take my result here and replace x with 3. That's 9 plus 12, which is 21. The difference of two functions practice. The same f of x and g of x from example 1 on the previous page. Find f minus g of x, then evaluate the difference for x equals 2. F minus g of x is equivalent to f of x minus g of x. 2x plus 1 minus, bold that subtraction, in parentheses with our trinomial because we have to subtract each term that follows. Alright, so I'm going to have a negative x squared. 2x minus 2x is 0. 1 minus negative 1 is 1 plus 1, which is 2. Now evaluating f minus g of 2, that'd be minus 2 squared is 4 plus 2, so negative 4 plus 2 is negative 2. Finding the product. right? F of x equals x squared, and g of x is now x minus 3. Find f of g of x, then evaluate the product when x equals 4. fg of x is equal to f of x times g of x. F of x is x squared times x minus 3, and distribute x to the third minus 3x squared. Cut the circle that. Now evaluating for an x value of 4. Four cubed minus 3 times 4 squared. That's 64 minus 3 times 16 is 48. 16. Finding the quotient of two functions. We want to find f divided by g of x and g divided by f of x for the functions given by f of x is equal to the square root of x and g of x is equal to 4 minus x squared. Then find the domains of f divided by g and g divided by x. Okay, so first f divided by g of x is going to equal f of x divided by g of x, which is the square root of x divided by 4 minus x squared. And there's nothing we can do there. There's no simplifying, so that's our answer. Now, for our domain, we can, for our numerator, we cannot take the square root of a negative number. It's not real. So our numerator, this x value underneath would have to be greater than or equal to 0. We can find the square root of 0, that's okay. So x has to be greater than or equal to 0. And here, we cannot have a denominator of 0, so if we were to replace this x in the denominator with a 2 or negative 2, that would result in 4 subtract 4. So x in the denominator cannot equal 2 or negative 2. So overall, all right, well, negative 2 is not greater than 0, so that's out. So overall, our domain is all values of x such that, I didn't give myself enough room, such that x is greater than or equal to 0 and does not equal 2. That is our domain. X has to be greater than or equal to 0, but not equal to 2. Now, for g divided by f of x, that's equal to g of x divided by f of x, which would equal 4 minus x squared over the square root of x, which does not simplify. Right. So for our numerator, we can put any number in for x, because it's okay if our numerator comes out to be 0. So our numerator x value is any real number. But our denominator, first, because it's square root, we can have a negative, and because it's in a denominator, we cannot have 0. So in this case, this has to be greater than 0. Our domain here, in green, would be the set of all x such that x is greater than 0. Exercise number 1, evaluate the indicated function for f of x equal to x squared plus 1 and g of x equal to x minus 4. F plus g of 2. That's going to equal f of 2 plus g of 2. F of 2, it's 2 squared plus 1, and g of 2, 2 minus 4. 4 plus 1 plus a negative 2, that's 5 minus 2 is 3. F minus g of negative 1 will be equivalent to f of negative 1 minus g of negative 1. Negative 1 squared plus 1, subtract negative 1 minus 4. 1 plus 1 is 2 minus negative 5. Fg of 0 is equivalent to f of 0 times g of 0. F of 0 is 0 squared plus 1 times g of 0, 0 minus 4. That's 1 times negative 4 is negative 4. And f divided by g of negative 2 is going to equal f of negative 2 divided by g of negative 2. F of negative 2, that's negative 2 squared plus 1, which is 5 divided by negative 2 minus 4. So 5 over negative 6. And our last exercise, evaluate the indicated function for f of x equal to the square root of x plus 4 and g of x equal to x cubed. F plus g of 0. F plus g of 0 will equal f of 0 plus g of 0. F of 0 be the square root of 0 plus 4, and g of 0, 0 cubed. It's the square root of 4, which is 2. Plus 0 is 2. F minus g of negative 3 will be equivalent to f of negative 3 subtract g of negative 3. F of negative 3 negative 3 plus 4 is 1, square root of 1 is 1, minus negative 3 cubed is negative 27, and 1 minus negative 27 is the same as 1 plus 27, which is 28. Fg of negative 5 is equivalent to f of negative 5 times g of negative 5. The square root of negative 5 plus 4 times negative 5 cubed. Negative 5 plus 4 is negative 1. The square root of negative 1 is equivalent to, remember, the imaginary number I times negative 125. So we would write this negative 125I. F divided by g of 5 is equivalent to f of 5 divided by g of 5. And f of 5 would be the square root of 5 plus 4 And g of 5 is 5 cubed, which is the square root of 9 over 125. And the square root of 9 is 3.